Okay, good morning, everyone. So we are going to start the second lecture, right? So before starting the second lecture, so what I am going to do is I'm just going to talk about the group and topic allocation, right? For the assignments. Since you all have several issues regarding the group and topic allocation, so here I'm going to talk about this group and topic allocation of the assignments, right? So when it comes to the group and topic allocation, normally it happens like this, right? So you can see group registration link will be, normally we are publishing the group registration link on the first year support page. Then you can register your group. So that means you can form your own group, 5 members group, and you can appoint a leader. So that leader can register their group. Only leader has to do that one, not any other. Only leader has to register their own 5 members group for that particular link, which is available on first year support page. Then once you submitted your group details, right, all the 5 members details, then there's a coordinator. That coordinator will assign random topic to you all, right? And then she will publish the topic and the group ID on the first year support page again. Then you can find what is the topic and what is your group ID once it's published, right? So this happens both Malame and the Metro groups, right? Normally. So you have to check first year support page, right? So that is regarding a group and topic allocation, right? That is regarding group and topic allocation. So any issues about the groups or something at the moment? Any issues, students? Any issues at the moment?
No, madam.
Okay. So now we are moving to the session outcomes, today's lecture actually. So as you remember, in very first lecture, what we have done is we have talk about what is software and what is software process and what is software process model and then software development life cycle, right? So here in this particular lecture, we are going to talk about and we are going to recall the memory of software process, SDLC, and the life cycle models. Then we are going to talk about in detailed manner the classical waterfall model, right? Very basic and very idealistic model. We are going to call classical waterfall model. We are going to talk about and we are going to discuss some main importance and main characteristics of classical waterfall model, right? So that's what we are going to do it today. So if you have anything, right, you have to keep remember, this is the very first place that you can learn this one. After this point, no one is going to introduce these topics after this particular lecture because these are very basic concepts. So if you have any issues, you have to tell it to me at that point, then we can talk about that one, right? So here, as you may know, right? So you have already know this one, what is the process and what is software process. So it includes set of interrelated activities and their associated result, which can transform input to the output. We talked about that one in last week, right? So what we are doing is in a process, we have set of interrelated activities that can transform inputs to the output, right? That is software process. So you can remember, right? Tea making process or whatever the cake making process. So what we are simply doing, we are transforming or we are converting the ingredients to the output. Same thing happens in the software engineering also, in software development. So in the software process, we have interrelated activities. So when we come to this software development process, there are 4 interrelated activities and their associated results that can produce the output or the software, right? So what are those? Can you remember? The first one, software specification, software development, and software validation, and software evolution. Now, when it comes to the software specification, what do you mean by software specification? We'll ask someone. So what is software specification? Like any other process, in the software development process also, there are some steps. Now, you can remember tea making process. The very first step is boiling the water. Likewise, in software development process, very first step is software specification. So what is software specification?
Specifying the requirements that we need for the software before developing.
Yes, right. So we have to come up with, right? We have to identify the requirements. Now, when it comes to now we'll say we are going to implement hotel management system for, we'll say Cinnamon Lake site. So in order to develop hotel management system, so what is the very first step? We have to identify their requirements. So according to the customer requirements, only we can come up with a proper system. So we have to ask them, and we have to conduct interviews, we can observe, and we can do surveys, and however we can ask from some of the customers, and we have to gather requirements, and then we have to analyze it, and we have to identify the requirements properly. So that is software specification. Once we done the requirements, once we identify those, and once we analyze, and once we identify the functions properly, we have to note it down, right, properly. So that is software specification. Identifying the requirements, analysis of the requirement, noting down the requirements, all are going to software specification. And software development. So for the Cinnamon Lake site, so what we can do in the development, software development, first of all, before implementing, before coding that one, what we have to do, we have to come up with a design. Then only we can go to the coding. So design and the implementation both goes to software development. And you know, right, when it comes to the Cinnamon Lake site, it's a very reputed cinnamon reputed hotel of the Cinnamon Group. So therefore, before delivering that product to them, what we have to do, we have to do the validation. Under validation, what we can do, we have to conduct testing. So we have to check whether this particular software is properly working, or we have to check whether that this particular software is exact software that customer requires. Okay, so that is software validation. And when it comes to software evolution, right, when it comes to software evolution, so what we are simply doing now, that under software evolution, we are talking about the maintenance. Now, you know, now once we deployed or once we install the system into Cinnamon Lake site, there can be some changes. Sometimes their requirements may change. Sometimes they may need a different environment. We have already implemented for Windows. Now they need it to iOS environment or the Apple laptops, right? So then we need to do those changes. So that evolution, that modification goes to software evolution phase, right? So those are the fundamental activities, right? So here you can see the same thing again, right? So what we are doing now here, when it comes to the software evolution, right, you know, each and everything, even in humans, we are changing time to time. Our requirements, our desires, our interests, our attitudes, our ways of talking, ways of dressing are time to time changing, right? Like in software also, you can see several ways of implementation. So we started from waterfall, classical, very idealistic model, and then we come to nowadays also we are working with agile, or the modern software development methodology is called Scrum, right? So now there's an emerging technology called DevOps, right? So you can later on you can read it and you can refer what is DevOps. So that is upcoming one. So likewise, time to time, software is need to be changed, right? Because of the requirements, because of the environmental change, because of some issues, right? So we have to change. So with the time. So so in this software development also, we can see that changes. So normally, the very 10 years back, we worked with waterfall, and then the iterative. Likewise, we have a set of models, right? Traditional models. Then nowadays we are working. Most of the companies, they apply agile or the modern software methodologies, right? So now the emerging one or the upcoming trend is DevOps. Okay. Now here, what is a SDLC? Now, software development life cycle. When we come to the software development, there's a life cycle. When we come to the software development, there's a life cycle. So it's like this, right? So for the software development, there's a life cycle. That means when we are developing a software, it has to go through some set of phases in order to come up with as a proper software, right? So here, the definition they are saying, the software development life cycle is a framework that defines activities performed throughout the software development process. That means in order to develop a proper software, each and every software has to go through these activities or the phases. Normally, we are starting with feasibility study, right? And then the requirement gathering and analysis and the designing and the implementation and the testing and the evolution. Okay, likewise, we have the steps. We are going to talk about these things, so no need to worry. Now, when we come to the software development life cycle or life cycle model or the software process model, so that is a descriptive and diagrammatic one, which has activities or which has a set of activities and the phases, okay, necessary for software development. So each and every software has to go through this particular phases or the activities, and there's a precedence of, there's an order of these activities when we come to the software process model or the life cycle model or the software development life cycle. Okay, so we are going to talk about this software development life cycle with using classical waterfall model. And when we have this kind of software development life cycle or the life cycle model or the software process model, we can see the systematic and disciplined software development. Why? When we are developing this one, we have a plan, we have phases. Throughout the development process, we have set of phases and the activities, right? And there's an order of the activities also. So that is systematic. We have a systematic plan. That is not the ad hoc method, right? So here, when we are developing a software, so that is also discipline. Why? How can we come up with this kind of a model? Because we based on the past experience, theories, and the methodologies and the tools. So that is discipline one. Now here, the life cycle model. For example, we can say under traditional approaches, we can say waterfall, incremental, prototyping, spiral, and unified process. In the lecture series, we are going to talk about waterfall, incremental, prototyping, and spiral only. You may learn unified process model and the V model in the labs or the tutorial session, right? So waterfall, incremental, prototyping, and spiral under traditional approaches. And when it comes to the modern ones, we can say agile and the secure software development. So at the latter part of the lecture series, as the last lecture, we are going to do the agile. So no need to worry. And secure software development at the moment we are not going to introduce, but however, if you prefer, you can refer those. So here we come to the life cycle models, and very first life cycle model called waterfall model, right? So here, before learning waterfall model or the classical waterfall model, I just need to mention this is very legacy, right? This is very outdated and very idealistic model that we have. This is the very first thing that you have to learn. And this is very basic, idealistic, and the outdated and the legacy one that we have. Still, we are learning this one. Why? Because even though it's legacy one, even though it's outdated one, this is the one that we are based on, right? For each and every new ones are based on this particular one. In order to learn software development life cycle, this is the one that we need. Okay, so even though this is legacy, even though this is outdated, even though this is very basic and simple one, this is the one that we have to base in software development life cycle and any other for the agile, scrum, any other models. This is the basement. So if you know this one properly, right, you can learn the rest of the thing very easily, unless you can't come up with a good idea if you don't know the waterfall model properly, right? So here, first of all, I just need to mention, I'll just go to the paint board with this one, right? Now here, when it comes to the this particular one, right? So this particular one, hope you can see the this paint board properly, right? So here, just 1 second. Can you see the paint board properly? Can you see the paint board?
Yes, yes, madam.
Okay. So here, this is the diagram of the classical waterfall model, right? So here, why we are saying it's a waterfall model? Why we are saying it's waterfall model? So here you can see, right? Here you can see the cascade of the phases. That means it's like this, right? Now, the very first step is feasibility study. Very first step is feasibility study. Then once you completed this phase, only we can go to the requirement gathering and analysis. Okay. Once you completed feasibility study only, you can go to the requirement gathering and analysis. Then once you completed requirement gathering and analysis only, you can go to the designing. Okay. Then you can, once you completed design only, you can go to the implementation. Then testing. Likewise, in this classical waterfall model, you can see several phases. So once you completed the very previous step only, you can go to the next. So why we are saying it's waterfall model? Here we can clearly see, right? We can clearly see the cascade of the phases. Okay. So that is like waterfall. Once we completed the previous one only, we can go to the next one. So because of this cascading, right? So we can say it is a waterfall model. Now, when it comes to this waterfall model, you have to keep remember there's an assumption, right? There's an assumption. What is the assumption? What is the assumption that we have? So we are assuming each and every step is smoothly going on. For example, now assume we started feasibility study. Now we finish that one. Now we come to the requirement gathering and analysis. Then now we have completed that one. Now we are on the designing. Then we are on the implementation. Assume now we are on the implementation. right? So when we are on the implementation, we feel some issues are in the designing phase, right? Some issues there can be, but in waterfall model, we are we have a kind of a assumption. What is that one? We are assuming all the phases are properly happening, right? No issues are arising in intermediate steps, right? So we have idealistic assumption. So that is practical situation that won't happen like that. But in classical waterfall model, we have that assumption. We are assuming no issues, no defects are arising in intermediate steps. We are only checking the issues in the testing phase. We are checking the issues or defects only in the testing phase. We are not checking any issues in any other phases. So we are checking the issues in the testing phase. If we have any issues, we have to go to this particular phase and we have to do it subsequently, right? So if there are any issues that we may find in a testing phase, so we have to go to the requirement gathering and analysis, and we have to correct it there and subsequently all the phases. So that is the classical waterfall model, right here. So when we come to this diagram, so this arrow should comes to the requirement gathering phase, right? So requirement gathering phase, it should be here, not feasibility study. I'll explain why that happens like that, right? So in waterfall model, right? So that is the very basic and idealistic and simple one, easy to learn and easy to use, right? Not the complex one. And we have another name for this classical waterfall model. What is that one? That is linear sequential model. Why we are saying it's linear sequential model or the linear model? Why? Because once we completed one's previous step, only we can go to the next step. So sequentially, we are moving, right? Once we done the feasibility study, only we can go to the requirement gathering and analysis. Once we done the requirement phase, only we can go to the design. If not, we can't go to the design. So that is sequence is there. And this waterfall model, also we are saying that is a document driven process. Why? The several documentation, detailed documentation we are maintaining with this classical waterfall model. For each and every step, there's a documentation, right? So here, we'll go to the very first step. Now we are going to learn feasibility study of the classical waterfall model. Very first step is feasibility study, right? Now, last week also we have discussed about feasibility study. Any idea? Any idea about the feasibility study?
Checking the financial costs to develop software, whether it's profitable.
Yes, that's the one thing. Yes, good. That is one thing. Any other facts? Any other facts? Rather than that, in addition to that one, any other facts? That's all. That is the one. The other one? Any idea? Now, when it comes to the feasibility,
technical feasibility.
Yes, technical feasibility. Good, right? Technically and finance, those ones are the main ones you have to keep remember. So in the feasibility study, what you are doing is, right, before starting the project, before accepting the project, team has to do a study. So that is a feasibility study. So in that one, what we are doing is, we are checking the possibility, whether we have a technical difficulties, whether we have a financial difficulties, right? Whether we have operational any issues, whether we have social environment any issues, culturally any issues, operationally any issues, right? So legally any issues. So each and every perspective we have to check this one before accepting the project, right? So once we done this study, we have a decision, right? We have to take the decision. We are accepting or rejecting the project, right? So once we accept this one, then that is the decision. Then we have to start the project. So before doing that one, we have to check whether this is technically feasible and financially worthwhile. So why we are checking those ones? Because sometimes technically there can be some difficulties. Sometimes some systems are not technically possible. If so, we cannot proceed that one. So therefore we have to check the technical perspective. Also, you have to understand the financial wise. Once we implemented this one, we have to check whether this one is profitable one or the valuable one or not. After finishing this one, if we feel that this is not the profitable one, that is a totally mess. So before doing the project, before accepting the project, you have to take that decision, right? Also, when we come to this feasibility study, in addition to those possibilities and the difficulties and the feasibility, and we are checking whether there are any alternative solutions, whether there are any existing systems, or do we need to build a new, totally new one, or totally innovation, right? So that one we have to check. So this is very first phase of the SDLC. So here what we are doing, once we done this study, we are going to take the decision, right? So here client and the company developing the software decide if they should keep the existing one, or else we have to build a new software. Now when we are doing this one, we have to think, right? Like I mentioned already in the previous lecture. Now when it comes to the China, they don't allow anyone to host social media, any other social media. They have different one, right? Because of some sort of reasons. So likewise, the culturally, social wise, and some operational wise, there can be some issues. Some of the countries for the toddlers, they don't allow each and every application, right? So some developed countries. So if we are implementing some kind of a communication application for toddlers in US or Canada or some other developed countries, we have to think a bit, right? Whether it's operationally can be uh, accommodate anything, or is it possible to host this kind of application to that kind of a country. So that technically, financially, we have to think, and we have to check whether there are existing solutions. If so, whether it's profitable to keep the existing one rather than the implementing new one. Likewise, we have to think, then do we really need to implement new one, right? So those things we are checking in the feasibility study. Now, to provide management with enough information to know, here are the things that we just need to check. Whether this project can be done. Technically feasibility, technical difficulties are there, expertise-wise difficulties are there, whether we have enough resources, whether we have enough expertise for this one. So that is what we are discussing on the project level. And this, whether the final product will benefit to the users. So we have to implement a software or the product that can be more profitable to society, right? That can be gain more profit, right? Why everything is trading these days without now. This is a kind of a we just need to have a target audience, right? So there should be some kind of a benefits, right? So then what are the alternative solutions, whether there are any existing ones? So do we really need to implement new one, or can we keep the existing one, right? And whether there is a preferred alternative or not, right? So the alternatives also there. If any alternatives are there, we have to check whether which one is the exact alternative that match with the requirement. So those ones we have to consider in the feasibility study. Now, once we done the feasibility study, we have to take the decision. whether we accept this project, or not. Once we accept it, then we have to proceed this one. Then we can't reverse it, right? So here, now, can you do a simple example for the library system, right? Feasibility criteria for library system, right? So not the library system, right? So actually library system is very, very simple one. So you have your own topic sometimes you can take, you can decide whatever the system that you are going to implement and just do this one. Can you write down 3 perspectives? First of all, you have to select the topic, the library management system, hotel management system, smart assistive robot, the chemical blasting system, a corona detection unit, then this disinfection unit, whatever the one you can select, and then write down 3 perspectives that you have to think before implementing this kind of application. Can you do it? Take a few seconds, right? Not 1 minute time, few seconds. Okay, we'll ask some answers, random answers. Anyone? Anyone? What is the system?
Online banking system.
Yes, online banking system. What are the perspectives?
Whether all the customers will use the online system, whether everyone will have access to online.
I didn't get it, What?
Whether all the customers will have access to the online portal.
Okay.
Because of the internet connections.
Okay, so before implementing the software, the possibility, right? The technical wise, the financial wise, and other perspectives. So when we are doing like that way, yes, obviously we can take. What else? What else? Any other answers?
Whether this will be profitable?
Yes, whether this one will be a profitable one. Good. Any other one?
Security purposes.
Yes, that's really good. Before implementing that kind of application, you have to check the security wise. Security wise also you have to check whether security wise, what are the things that we have to consider. The feasibility of security perspective. Good. So what else? What else? What else? Any other? Okay, that's really good, right? So you have one example and you have to think about. Now in the lab session also there's a separate exercise. You can do it in the lab session, so then you can have a more idea. So then the second phase, right? Once you have taken the decision, then next phase is requirement phase. Now in the requirement phase, it's the second phase, or else when we come to the most of the SDLC, requirement phase is the very first phase, because that one is a decision. The feasibility study is a decision. Once we have taken the decision, then we are directly going to the requirement. So some of the SDLC, very first phase is requirement phase. That's also we can take. Now what we are doing in the requirement phase, here the basic thing is we have to understand customers' requirements. We have to understand customers' requirements. Why? We are implementing this system for the customers. Now, the banking system, we are implementing that banking system for the bankers or the clients, right? So, we have to accommodate their requirements, not our ones. So, we have to empathize, right? We have to understand their requirements properly. So that is the aim of requirement phase. So if we can't understand the requirement phase, what requirements of the customer, what will happen? Sometimes they may need the car. We are going to end up with a bicycle. Then totally mess, right? So likewise, we have to identify the requirements properly. Okay. Sometimes this customer can be a single person, sometimes it's a group of people, sometimes a company, sometimes an organization, sometimes an institution. There can be a range of customers. Sometimes the target audience is very critical. So in order to identify their exact requirements, sometimes, for example, right? This is very famous example, right? So there's a software company will say ABC. Now ABC is going to implement harvest predicting system or the weather predicting system for the farmers in Horopatana or some other rural area, right? So how can we identify their requirements, right? So they are the farmers, they are very non-technical people, they don't know how to operate smartphones, right? So if we are going to implement a mobile application for predict the weather as a support application to the farmers, so we have to understand their requirements, right? So as we are in the we are working in the modern technology, we are in the modern environment. So sometimes we have a kind of a difficulty to understand exact farmers' requirements, right? So the requirement phase is very important. If we identify the requirement steps only, we can implement a proper system, right? Otherwise it will totally mess. So in the requirement phase, there are two things that we have to consider. The very first thing is requirement gathering and analysis and the requirement specification. First of all, we have to collect the requirements from the customers and the target audience. Then we have to analyze it. Then we have to identify, when we are analyzing, we have to identify each and everything, right? So we'll do those ones in the requirement engineering lecture. So then once we analyze those ones, then we have to note it down, right? We have to document it. So that documentation part, we are calling it as a requirement specification. We are gathering, we are analyzing, and we are making the documentation. So that is requirement gathering, requirement analysis, and requirement specification. And requirement gathering, there's another name. What is that one? Requirements elicitation. The requirement gathering, there's another synonym. Another name called requirement elicitation. You have to keep remember that word is very important for the midterm and the finals and all those ones. That's why I'm introducing. Requirement elicitation is requirement gathering, right? No any other definition. So here, now when we are gathering the requirements, right? So when we are doing the requirement elicitation or requirement gathering, so what we have to do, we have to gather requirements from each and every person that involved to the system. So they are stakeholders. Who are the stakeholders? Now we'll say we are going to implement weather predicting system for the farmers. Who are the stakeholders of that system? Stakeholders? Who are the stakeholders of that system? People
who own it.
Yes.
Managers, employees, customers.
Yes, all the people. Yes, good. All the people who interact, who may affect from the system. Clients, the software engineers, and each and every people. The people who are developing, people who are using, people who are affording money. So each and every person is a stakeholder of that one. The people who affect from that system. So they are stakeholders. So we have to gather requirements from each and every stakeholder, right? Then only we can come up with a proper software. Who will use the system, how they will use the system, and what will be the input and what will be the output, what exactly they need to see as the output. So we have to check in this requirement gathering. So there are several ways of conducting requirement gathering or the requirement elicitation. You can do the interviews, you can do the observation, you can do the survey, questionnaire, discussion, or you can go and you can discuss directly, you can empathize, right? Several methods are there. And analysis, right? So why? Once we gather requirements, why we analyze? Why we analyze? Sometimes we are collecting the requirements from non-technical persons. Sometimes we are gathering requirements from different audience, toddlers, small children, then teenagers, farmers, and very technical peoples like software engineers, sometimes the management teams. So according to their perspective, the requirements are different, right? So we have to identify exact thing that they are expressing, exact need of them. Sometimes user may say, I need very user-friendly system. So we have to understand which kind of user-friendliness that they ask. So we have to determine what is the input, what is the processing, and what will be the output, and what are the characteristics, and what are the difficulties, and what are the constraints. So likewise, you have to analyze each and every, what are the main functions, what are the non-functional requirements, what are the constraints. So likewise, you have to analyze it in analysis phase, right? And the thing is, this requirement analysis phase, you are not considering, right? The requirement analysis phase, you are not considering how it happens. We are not worrying about how it happens. We are just talking about what exactly happens, what we have to implement, what are the functions that we have to implement, what are the components we have to deliver as a software. So, but we are not worrying how it happens in the requirement analysis stage or the requirements phase. Then the requirement specification. So once now we collected the requirement, we analyze it. Now we are going to document it, or requirement specification. Now under requirement specification, we have to document the requirements that we analyze. So that specification, we are calling it as SRS, or the software requirement specification, or system requirement specification. So we'll go to the paint board. Now we are here, right? So first one is feasibility study, right? In feasibility study, as an output, right? As an output, we have a decision, right? We have a decision, right? We have a decision. Then once we have the decision only, then we are moving to the next step, right? So what is the next step? Next step is requirement phase. Now requirement phase, we have several things. So what are the several things? We have to gather requirements, we have to analyze requirements, and then we have to have a requirement documentation or the specification. So what is the input of this one? We have a set of requirements. Okay, we have set of requirements. As the output of this one, we can have a SRS. As an output, we can have a SRS. What is SRS? SRS is software requirement specification or system requirement specification. So once we gather requirements, once we analyze the requirements, then we have to document that one. So that documentation or that specification, we are calling it as SRS. Now this SRS is very important to know. So there are some few points that you have to keep remember about SRS. Now SRS is a legal contract. So what you need to keep remember about SRS? SRS is legal contract. Normally, business analyst or system analyst, or the person who analyze the requirement prepare this SRS or the specification or this documentation and hand over to the customer after requirement phase. So business analyst or the system analyst hand over this specification to the customer. Then customer or the client. Now we'll say the banking system. We'll assume we are going to implement a banking system for Sampath Bank. Now our client is Sampath Bank. Now we'll say we are the software engineering team in the IFS. We'll say like that. So when it comes to the BA of our team, we'll analyze the requirement and prepare this documentation, and that BA will hand over that one to the Sampath Bank management. So they are the customers. So the customer has to read it very properly, each and everything in that documentation, and he or she has to, the representative of the Sampath Bank has to sign in that SRS. And both software engineering team and the client, they have to sign in the SRS. Why? So we are agreeing to, in our software engineering team side, we are agreeing to implement those ones. And the customer side, they are signing to agree. So that's what they need from us. Okay. So we both parties has to sign. Once both parties have signed that documentation, then that documentation is working it as a legal contract or the legal documentation between software engineers and the customers, right? So that is the contract or the legal documentation in between software engineering team and the client. So that is the legal contract or the negotiation or the contract between us, right? So that is SRS. In SRS, normally you have to keep remember SRS, we have to mention each and everything happens. So we are normally include what happens in the system, but we are not mentioning how it happens. In SRS, we are just mentioning what happens. We are not mentioning how it happens. Why we are not mentioning how it happens? Because client also reading that one. So client cannot understand the technical terms. Therefore, we are not including any technical terms or how it happens in the SRS. That is natural language or the plain English. And both people can read it and sign it. Once we sign that SRS or system or software requirement specification, that works as a legal contract or the negotiation or the legal documentation between software engineers and the clients. Then those requirement set is the fixed requirement set that we are going to implement. No any other requirements after that point, right? So that is the requirement set that we agree with as a software engineers. And the customers also, sometimes customer may have a different set of requirements, but we are not worrying because these are the ones that we agree with. So here we are strictly implementing these set of requirements. So that is the output of requirement phase. Okay. So then, normally SRS forms the basis of legal contract with the customer. So software engineers who specialize in the requirement engineering, analysis and specification are called system, business or requirement analyst or business analyst, system analyst or the requirement analyst can do this one properly. Okay. And when we are designing the system, right? So the third phase is once we gather the requirement set, once we identify the proper requirement set, then the other thing is, then the next phase is the designing phase. So here, so we are not going to talk more about the design phase in this particular lecture because we have separate lecture for design. So here, you know, like any other thing, any other implementation, we'll say house, before implementing the house, we have to have proper design. Once we design only, we can have a exact and the proper implementation. So architectural wise, So the high level wise, we have two types of designing, that is architectural design and the low level design. The high level design and the low level design, or the architectural design and the low level design. So we have two types of designing, high level and the low level design, right? So once we design, so in this particular one also we have documentation, right? So the next step is the designing. Once we gather the requirement, so next step is the designing, right? Designing. So in the designing also we have, now what is the input for the designing? So the input is SRS and output is SDS, software design specification or system design specification. So this is another documentation. Okay. So we can have another documentation as the output. We'll talk about later on. So this is a separate lecture, right? So that is designing. Okay. So design specification document or the software design specification, or both terms are correct. So design specification document or DSD or the software design specification, both terms are correct, right? So so here we can take this DSD or SDS. So then when it comes to the development, right? So when it comes to the development, so the next phase is implementation or the development. Okay. So once we done this one, that is development or the implementation. So what we are doing, we are using SRS and DSD or SDS, right? So here we have the development phase. In the development phase, what we are doing, we are converting design into working product, right? We are simply converting a design into a working product, right? So here, what we have normally in any company, now when it comes to the developing a banking system for the Sampath Bank, there can be a team of developers. So among team of the developers, they can divide components of the system, and the set of developers are coding or the programming and implementing the system according to the specification, SRS and DSD, design specification document, right? Or software design specification. Okay, so whatever the documentation, so with using that one, they will implement or program or code the one or converting the design into the working product, right? So then the development phase also, there's some kind of a testing, right? So each and every developer is responsible. Now each and every developer has to implement a part of the system, right? We'll say calculate salary calculation, or account section is handling, there are two developers who handling the account section, we'll say like that. So those two developers are responsible to go through each and every line of the coding and whether it's properly working or not. So that particular testing also includes in this development phase. So each and every development, now when we are developing that one as a software engineer, once we implement the part of the software, we are responsible to check that one before giving it to the integration. Before integrate to each and every component together, as the individual part, we have to check whether they are properly working or not. So the developer or the person who implement it is responsible to check that component. So that particular testing goes to the development. So once the development done, then we have to integrate it, right? Once the integration happens, then the next phase is testing, right? So here, once we developed it, and then we have to have a integration. Then once we done the integration, then the next step is testing. So in testing, what we are doing is we are basically checking, right? We are basically checking two things. Obviously, we are checking whether there are any defects or whether there are any issues, right? Whether there are any defects or whether there are any issues. That's obviously we are doing in the testing, whether there are any errors, issues, or defects. So that is obviously we are doing in the testing. In addition to that one, not addition, there's another important thing that we have to check. What is that one? We have to check whether this product is the exact product that customer need. Right? Sometimes customer needs something, but we have implemented a different thing. So we have to check whether this is the one that the customer exactly need. So those two things we are checking in the testing phase. So the testing phase ensure that the software requirements are in a place that software works as expected. So we are checking the requirements. That means whether we have implemented all the requirements that we have agreed in the SRS, and whether any issues, whether there are any defects, whether there are any errors, okay, and whether this software is properly working or appropriately giving the input, giving the outputs, right? So those things we are checking in the testing, right? And the thing is, if there are any issues, if there are any defects, what we have to do, we have to fix it and we have to create a new version. Okay, so in the testing phase, we have to do it again and again. There are several versions, right? So then once we have confident enough, that is error-free one. So to be honest, we cannot say that is 100% error-free one, but as much as the team can, so they have to mitigate the errors, and then it's ready to deploy in the current customer premises. So that is testing. And then the sixth phase is deployment or installation in the customer place and the maintenance. Right? Once the software is error-free, it is deployed into the operating environment. So we can confidently say that is error-free. There can be some issues. We can say it's 100 error-free one. There can be some, but as much as we can, right? So then we can deploy in the operating environment. So then while the customers are using the software, any issues will be brought into the attention to the maintenance team. So even though you check your system in the millions and the billion times, when it operates, there can be small issues. Not so small issues, sometimes there may be some other issues also. So as a development team, we have to fix it. And the other thing is, sometimes they requested it for Windows, but after some time they may need an environmental change to the iOS. Then we have to change it to the iOS. Sometimes according to the requirement of the market, according to the some client requirements, sometimes we have to add some new functionalities with it. So we'll say, for example, initially we have implemented into the fingerprint, but later on due to this pandemic, now they need the face recognition one, because fingerprint is much risky when it comes to the pandemic situation. So we have to accommodate those ones. Okay, so that is deployment and the maintenance. Okay, so when it comes to the waterfall, here you have to keep remember in the waterfall one, right? So we are aligned with the set of the requirements that we agree in the SRS. We cannot change any requirements once we signed it, right? So the requirement set is fixed, right? Requirement set is fixed. Okay. So then, but the time and the budget, and when we consider the time and the budget may vary. but the requirement set is fixed, right? So that is a kind of a disadvantage. So we'll say what are the advantages and the disadvantages. Now, in this classical waterfall model, or the classical waterfall model, it has these phases, also software development life cycle, these are the phases. Now, when it comes to the classical waterfall model, right? So this one is very simple, idealistic, and basic one, and very simple to use and easy to manage, right? But, right, so, and the thing is, if this one is very appropriate if we have a crystal clear requirement set. This is very good place. This is very good one for crystal clear requirement set. And set the requirement set is fixed. We cannot accommodate any other requirements rather than the requirements that we have mentioned in SRS. And this is works well for small projects. And if the requirement set is well understood and crystal clear. Okay. And when we come to the time and the budget, right? Time and the budget may vary, right? Time and the budget vary, and the weaknesses, right? So there are some sort of weaknesses or the disadvantages in this one. As you may know now, I already mentioned, right? So in each and every step, right, we are assuming no issues are arising. We are only checking the issues in the latter part of the cycle. Now here, when we come to this classical waterfall model, the requirement phase, designing, development, and testing. Then the maintenance is there, right? The maintenance is there as a last step, right? So in requirements and the designing or the development, we are not checking any issues. We are checking the issues only in the testing phase. That means we are waiting until the latter part of the cycle to check the requirements, right? What is the issue in that one? Now we cannot go back and do anything. Once we check the issues in the testing phase, so we'll take that lecture slide and then we'll explain with that one. Then it will be a kind of a easy. This one, right? Now here, right? So here you can see the now we are checking each and every issue in the testing phase. Now the testing phase is the latter part of the cycle. So here in the analysis and the design and the implementation, we are not checking any issues. We are assuming, we have assumption in a classical waterfall model. No any other issues, no defects, no issues are arising in the intermediate steps. We have assumption. We are only checking the issues in the testing phase. So that is a kind of a disadvantage. We are waiting until the latter part of the cycle. So the time-wise, the cost-wise, it's a disadvantage. Why? Now assume, now we are on the implementation stage. We will assume now we are on the implementation stage. We feel some issues are in the designing, right? Now when we are on the implementation, we feel something wrong in designing phase. But we cannot go back. We don't have backward path in the classical waterfall model. We can't go back and do the correction in the design phase. We have to wait until the testing phase. When we come to the testing phase, only we can check those ones. If we find the issues in the design phase, then what we have to do? We have to go to the analysis phase. And we have to do the correction in that one. Then we come to the designing. And then we have to do the correction. And then we come to the implementation. Then we have to do that one. And then we come to again to the testing. Right? That's the way of correction in the classical waterfall model. Now, because of this one, because we are waiting until the latter part of the cycle, we need much time and much, the human wise also, we have to afford, we have much effort to fix those, to find where the place that happens. Now, if there's a way to go back, right, previous step, and we can easily fix it. Now, assume now we are on the implementation stage, but we feel something have wrong in the design. If there's a way to go back and directly check, correct that place, that will be a kind of a easy way. But the thing is, we don't have that one. We have to wait until the testing phase to check each and everything. So that is the issue. And the other thing is, when we come to the customer's perspective, customers given requirements in this particular phase, and they can see product in the latter part, right? They can see latter part of the cycle, right? The latter part of the cycle only they can see the working product. So they cannot see what exactly happened in this time period. So that is, customer involvement is very less. So therefore, sometimes we may come up with a different thing that than customer expect. Then that is a kind of a disadvantage. And again, the sometimes according to the customer, there may be some requirement changes, right? Requirement can be changed. That means, according to the market value, according to some other information, sometimes requirements are changing. But the thing is, we cannot accommodate any late requirements. We cannot accept any late requirements in the classical waterfall model, because we are based on the SRS, the things that we agree, right? We can't change this SRS. So that is another disadvantage. Okay. So customer involvement is very less. Customer cannot see the working product, and we are waiting and waiting up to the testing phase to check each and everything, right? So late requirements are not acceptable, right? What else? And when we come to the very complex project, this is not good for very complex ones. Why? Because if the requirement set is very clear, crystal clear, only we can go to the classical waterfall model, right? So here, now what are the weaknesses that we mentioned in the lecture slides? No working software produced until the end. Customer can see the working product until the latter part of the cycle. High uncertainty. Why? Now, because the customer involvement is less, right? We are working with the development team. So we are not taking the customer feedback, anything, right? Because of that, sometimes we are ending up with a different thing, right? And the thing is, again, we are waiting up to the testing phase to check the issue. Sometimes end of the in the testing phase, there's a kind of a huge mess, right? We cannot find where errors are rising, and where the place that are happening the errors, where the point of the introduction we cannot find. So series of serious errors can be discovered in the testing phase. Then after requirement phase, there is no formal way to make changes. So the late requirements are not acceptable in the classical waterfall model. And this one is not good for the complex projects where the requirements are changing and high risk and the safety critical system. This is the not good one. This one is not good for those situations. This one is very good for the small projects and the projects which are very clear, the clear set of requirements. In some cases, if some people needs, sometimes they need very quality, right? Very quality product than the budget and the time, right? So in this classical waterfall model, the budget and time always are dragging, right? Budget is not the fixed budget, and the time also not the fixed budget. If we are applying waterfall, it may take much time and much cost for this one to fix the errors and each and everything, right? But if any person need the quality product rather than the budget and the time, they don't need to worry about the time and budget, they can go for this one. But however, this one is very good for simple small project which has a set of clear requirements. If the requirement set is clear only, we can apply classical waterfall model, unless we can't do this one. Okay. Now these are the places that we can use the waterfall model. If requirement set is clearly defined and known, and product definition is stable, and if we have a prior experience, the technology also very matured, and we have the prior experience, and now we are going to implement new version of the existing one, so then only we can go to the classical waterfall model. Also, the technologies and tools are well known, and we have ample or plenty of resources and required expertise, and we have that much of experience, we can go to the classical waterfall model. Okay. So then, can you note down whatever the things that you need to know about the classical waterfall model? Can you make a summary of the classical waterfall model? And I just need to mention, we'll talk about it iterative then later on, right? Take 1 minute and summarize whatever the thing that you need. Okay, right. So, any issues in the classical waterfall model? Any issues in the classical waterfall model? Yes, anything?
No, ma'am.
Okay, so here we are moving to the iterative. I am only doing up to iterative. Otherwise, we have to do it the classical waterfall model again to do the iterative. That's why I'm completing iterative also today. Now, iterative waterfall model. Now, Now we already discussed about the classical waterfall model, right? The classical waterfall model. So in that one, the main disadvantage is we cannot go the previous step, right? We cannot go backward, and we cannot go backward, and we cannot do the modification, right? If we can go to the previous phase and modify that one, we can easily fix the issues. Right now, if we are on the development phase, if we feel something wrong in the design phase, there should be a way to go back, and if we have a way to go back and fix it in the design phase and then come back to the development, then the time consumption of fixing that error is very less, and the effort also very less, right? Because that is the point of introduction. We can clearly understand the previous phase that is happening. So then we can do that one. But when we are waiting up to the testing phase, what will happen? So there may be several issues together we can find in the testing phase. Then we have to check each and every phase. We have to check each and every phase, and it will take much time. Not the time, actually, the effort. You have to afford a much effort to find it, where it happens, right? So in order to fix that one, we have another model called iterative waterfall model. In this iterative waterfall model, we have a backward paths rather than the classical waterfall model, right? Now, in the classical waterfall model, we have an assumption. No issues are arising in the intermediate steps. That's why we don't have backward paths in the classical waterfall model. There's an assumption. We are checking on the issues in the testing only. No any other defects or issues are arising in the intermediate steps. That's what we assuming in the classical waterfall model. But realistic situation, actual situation is not like that. In each and every place, there can be some issues, right? So we can say that is 100% crystal clear, no issues are happening, intermediate steps, right? So therefore, in order to cater this particular disadvantage, in order to fix this one, we have iterative waterfall model, right? Normally in practice, intermediate steps, there are some issues. So if we can go the previous phase, and if we can easily fix that one, we can do it in much less money and less time, and the less cost, and the less effort, right? So then here we added, right? We added the feedback parts for the classical waterfall model, right? Now assume we have issues in the, now we feel something happens in the design, then we can go back to the design phase and we can fix it and we can come back, right? So the time is less, effort is less, and cost also less, right? So we can go back for each and every phase. So feedback path is added to the classical waterfall model, and we have fixed it called iterative waterfall model, right? So in the iterative waterfall model, what we are doing, we have added the backward paths rather than the classical waterfall model. That's only difference that we have when we compare classical waterfall model and the iterative waterfall model. But right, you can see there isn't any backward path from analysis and specification to feasibility study. Why? We cannot see any backward paths to the feasibility study. Why? Because feasibility study is a study that we are taking the decision, right? That we are taking the decision. So we are not, once we have taken the decision, then we have to implement it. We cannot reverse the decision. That is a decision, right? So then because of that, we don't have backward path for the feasibility study, right? The rest of the phases, we have the backward paths. The feasibility study, we have taken the decision. So we cannot change that decision once we have taken. Here we accepted the project. Once we accepted it, we cannot backward, right? We cannot reject after some time. So we don't have backward path from analysis to the feasibility study. The rest of the thing we have backward path. Now the strengths rather than the classical waterfall model, the strength is we can identify the defects and fix it early through the feedback path. That means when it arises at the same point of the introduction, we can identify and we can fix it, right? So then it will need much time, much cost. So it will need less time and less cost and less effort, right? Since we have the feedback path or the backward paths to the previous step. Okay. And the weaknesses, still it has the same weaknesses rather than that the latter part of the cycle that we are introducing there as in the classical waterfall model. Rather than that one, the same weaknesses set is applicable to the iterative waterfall model also. The requirement set is fixed and the customer involvement is less. The late requirements cannot be acceptable. Customer cannot see the working product in the previous phases. So those are the weaknesses in the iterative waterfall model rather than the classical, the classical waterfall models also the same set of weaknesses are there. But here we only fixed one issue in the classical waterfall model, that is the feedback path. We have introduced a feedback path in the iterative waterfall model. So with using that one, we can fix the issues directly at the point of the interaction. So we can easily fix it with using less time, less cost, and less effort, right? So that is iterative waterfall model. So the iterative waterfall model also very suitable for small projects which has limited functionalities. The requirement set should be crystal clear for the iterative waterfall model. And if we have past experiences of the technology or the tools, if we have the resources, ample of the resources, and if we have to implement the very familiar system that we already implemented in several times, so then we can apply iterative waterfall model. Okay. So that is iterative waterfall model. Okay. So any issues after this point? Any issues after this point? Any issues after this point? Okay. Then that is two life cycle models, the very basic two life cycle models. Next week you have small activity, right? So before once now we are normally starting at 10:30. So 10:30 to 10:35, randomly I'm asking someone to tell the summary of classical waterfall model and the incremental model, right? So for that one, you have to prepare the summary of classical waterfall model. What is the classical waterfall model, and what are the features, and what is the diagram, and what are the advantages and the disadvantages, where are the places that we can apply. Okay. So summary, you have to make the summary and you have to tell it to the other students. So randomly I'm asking someone to tell it to the class, right? So for both cases you have to ready iterative and the classical waterfall model. So that is the homework today, right? So that's all. Question. The thing is, it's encouraged you to group within the same batch, right? Someone asked to form a groups with the Metro weekday students, so we are encouraging you to group within the same batch. Okay. Okay.
Madam, there are only 9 of us. So one group is 4 members and one is 5.
Okay, no need to worry. No need to worry. Right? No need to worry.
Can be 4 members, right? One group can be 4 and other can be 5.
No, normally in your batch it's 9, right?
Yeah.
If so, no need to worry. So if now the thing is, actually you have to talk with the coordinators in Metro campus, right? So the people who allocate, I'll just discuss with the coordinator who allocate the random topics to you all, and I'll ask that one, and I'll inform it in next week. Okay. So at the moment, there's a group registration link on the first year support page. Is it?
No, madam.
Okay. Not yet.
Not yet.
Okay. I'll ask to put the course notice for that one as well. So the members, how many members, and how can you create the group with this batch or with some other batches likewise. I'll ask them to make it the notice and make it available on the course web. Okay. Okay. So that's all for today, right? So I feel that if 9 students are in your batch, the recommended way is 5 and 4, right? So at the moment you have to keep remember. So I'll discuss with them and I'll let you know whether you can take one member from the Metro Week day 1, right? So I'll discuss with them and let you know. Thank you very much for listening, and please do homework and come. Why I am asking to do this kind of a small homework, because uh, last time more so, right? Last time more so, um, last time there's a 85% pass rate in SPM, so that's really good pass rate. Still there are plenty of queries, right? Students are asking, right? Now, as you may know, the very first lectures I explained, right? In the assignment in 1 and 2, we are taking only 20% students, right? So the final examination, we are directly taking 50%. If you have 100 from the assignment 1 and 2, even though you have 200 from the assignments, but then if you haven't done the final examination properly, 30 or 24 marks out of 100, we can't do anything, right? We can't do anything. There are several queries. Students are crying. They were crying and asking me to pass the one, because I can't do like that. If you write it properly only, I can do it, right? If you are on the borderline, surely you can pass. But the thing is, some students are not even in the on the borderline. That's the case. So I don't like that kind of a situation, because you are students, you are children. So I exactly treating you as my own children. I don't like uh, that kind of situation. I just need you all to take A passes. Therefore, so we have to do our finals and midterm very properly, right? Then only you can properly take the marks, right, for those ones. Then you can gain A surely. So that's why I'm asking to create this short notes this time onwards, right? So please create that one.
Midterms is only MCQ, right?
Yes, midterm one is on our MCQ one. That is even it comes to the pandemic or the previous situation, that is online. 1 hour online paper, MCQ one, minus marks also there. Okay. Okay, so that's all today. Thank you very much for listening. Any other issues? Any other issues?